Welcome to section 1.4, radical equations, equations in radical form, and factorable equations. We're going to go through 4 examples together. Feel free to pause the video and try working the problem ahead of me, and we'll go through it together. And you can start writing down example 1 here. So we're going to solve for x here. This is a radical equation because of the fact that it has a square root sign in it. So we're going to get rid of the square root, and the opposite of square rooting is to square each side of the equation. So I'm going to begin by squaring each side of the equation. You also have to watch out for extraneous solutions when you do radical equations. You want to make sure that the solution works back in the original problem. All right, continuing on from squaring each side, we get x squared minus x minus 4 is equal to. Now when you square a binomial like x plus 2 squared, you have to remember, always remember, write it down twice. And then that way you don't think that it's x squared plus 4 because there is that middle term there. Okay, copying this down over here on the left side. And then we're going to start multiplying through. X squared, and then we get 2x, and then we get another 2x, and then the 2 times 2 is the 4. So these get added together. So we get x squared minus x minus 4 is equal to x squared plus 4x plus 4. So this is asking the question, when is the parabola on the left-hand side of the equation? Because this makes a parabola, and then that makes a parabola. When are the two parabolas equal to each other? That's the question here. And there's only one solution to this. All right, so what is that one solution? Well, as soon as we subtract x squared on each side of the equation, then we're down to just a linear problem. So the minus x drops down, the minus 4 drops down, and the 4x plus 4 drops down. So it's no longer an x squared equation, it's just an x equation. So this is an algebra 1 problem now. We get the x's on the same side, so I'm going to add over the x. And I'm going to get the 4's on the same side, so I'm going to subtract over the 4. And then I get these to cancel out. We're left with negative 8 is equal to, that's a 1 right there, so it's 5x. Divide the 5 over, so negative 8/5 is equal to x. And if you take that negative 8/5 and put it back in the original equation, it won't be taking the square root of a negative, and it is a good solution. So there's one solution to this, and that's all you get. Okay, we're going to do one more radical equation, example 2, where you have a double square root. So we have the square root, and then we have a square root underneath. So this is kind of a tricky one where you have to actually square each side of the equation twice is what we're going to see. So we're going to square each side. When we do that, we're left with 10 plus 3 square root of x is equal to x. So squaring and square rooting cancel each other out, so the x drops down, and then the squaring and square rooting cancel out, but it won't cancel out this square root. This one right here will not won't go away until we square each side of the equation again. To do that, we need to isolate that radical by moving the 10 over. So I'm going to subtract the 10 over to the other side of the equation, because you can't really square each side now because you'll just create more square roots. So we need to isolate the radical. So 3 square root of x is equal to x minus 10. Now, it's okay to leave that 3 there. So I'm going to square each side of the equation again. And I got that whole binomial thing, so I have to write it down twice. Whoops, I'm going to go back to black. So squaring here, 3 squared is 9, so I get 9, and then the x, of course, is what I want. And then this has to be written down twice like we did before, and it's got to be FOILed out. So we get 9x is equal to the x and the x multiply together, make x squared. There's a negative 10x, and then negative 10x again, and plus 100. Now we got to get everything to one side of the equation, so I'm going to subtract over 9x and put all of this together. So I have x squared And I have minus 10, and minus 9 all put together would be minus 29x plus 100 is equal to 0. Now we're to a simple quadratic that will factor. So we get x and x. 29. Well, 25 and 4 make the 29, so that's what it is, minus 25 and minus 4. Zero product property gives me two solutions here. Gives me a positive 25 as one solution, and it gives me a positive 4 as another solution. Now what happens is when you take the 4 solution, you put it back in the original problem. I'm going to switch to a different color here. How about red? If we put the 4 solution down here back in the original problem, it will not work. So watch this. X equals 4 is my solution. Put it in. Square root of 10 plus 3 times the square root of 4 is equal to the square root of 4. So that's 2 times 3 is 6, and then plus 10. So the square root of 16 is equal to the square root of 4. That's not true because the square root of 16 is 4, and the square root of 4 is 2. So these are not equal, so that's a bad solution. So we go ahead and we cross that solution out. And when you cross the solution out, because it doesn't work in the original problem, it's called an extraneous solution. So that's what we call it. So the only solution that does work is the 25. Okay, next example is a U substitution problem. So we have the quantity 2x plus 5 squared, and then we have minus the quantity 2x plus 5. So notice those are both 2x plus 5s. So what we're going to do is we're going to say that u is equal to 2x plus 5. So we can make this look a lot simpler by putting in a u instead of the 2x plus 5. U is a standard variable to substitute in for some reason. That's been kind of the standard here. So instead of the 2x plus 5, we put in u, and that's squared, minus u minus 6 is equal to 0. And that looks a whole lot easier to solve, doesn't it, versus the other one. So you just kind of ignore this part up right here, and you just solve the u equation now, and then we'll go back in and figure out what x should be. So this does factor u, and then equals 0. How about 3 and 2? Negative 3, positive 2. That should work. Zero product property. U minus 3 is equal to 0. Therefore, u is 3. So that's one solution for u, but remember, we got to find x. And then u plus 2 is equal to 0. U is equal to negative 2. So we need to go over here and go back to the world of u and figure out what u should be. So I'll make a little box off like this, and we'll get the red pin out. So what is u? U is 3. So we can say 3 is equal to 2x plus 5. So that's one answer for u. The other answer for u is negative 2. So we can do negative 2 is equal to 2x plus 5. So now I solve those two little baby equations, and I get 2 answers for x, which would work back in the original problem. All right, subtract the 5 over, and we get negative 2 is equal to 2x. So divide the 2 over, and we get negative 1 is equal to x. So that's one solution for x. Then we're going to subtract the 5 over again, same steps, and we get negative 7 is equal to 2x. Divide the 2 over, negative 7 halves is equal to 2. So negative 7 halves or negative 3.5 and negative 1 are the two solutions that make this equation jive. But see, by getting rid of the 2x plus 5 and calling it u, we made a much easier equation to deal with. All right, last example is factoring by grouping, and we did some practice with this, just the factoring part, but we never solved. So we're solving for x, And the method that we're using is factoring by grouping. So we're going to get everything to the same side of the equation. So I have 2x cubed, not squared. So let me get rid of that, change that to cubed. We're going to subtract over the x squared, subtract over the 8x, and we're going to keep the 4 there. Now we have a polynomial set equal to 0. So instead of a quadratic set equal to 0, we have x cubed set equal to 0. And what we want to do is we want to break this into its two parts, group it together, and factor those two parts and hope for a common factor in between. So looking at the first group there, 2x cubed minus x squared, the x squared would be the common factor, leaving 2x minus 1. Then the next one has the common factor of just 4. But we don't want to take out 4 because we need it to match the 2x minus 1. So the trick here is to take out negative 4, and then that'll leave 2x minus 1. So if I distribute the x squared back through and the negative 4 back through, it'll make the original problem. But look what's happened here. La la la, magic. These are the same. So those get factored to the front, and then it just leaves the x squared minus 4. So 2x minus 1 gets factored to the front, and then we're left with x squared minus 4 equals 0. Then we do 0 product property. Property. So we get 2x minus 1 is equal to 0. X squared minus 4 is equal to 0. Add over the 1. Divide 1/2. And then we're going to add over the 4. We get x squared is equal to 4. Then when you take the square root of each side of the equation, don't forget the plus or minus, x is equal to plus or minus 2. So we do get 4 solutions. We get 1/2, we get 2, and we get negative 2. So those are the 3 solutions that make this equation true. So there it is. That's section 1.4. There's just kind of different equations in here to solve. And the name of the section is radical equations, equations in quadratic form, and factorable equations.